Glass-making chemistry. Akshat's kiln opened a new world of possibilities. As he watched the flames dance and the clay bricks glow, he remembered stories of ancient civilizations, how they transformed sand into glass, turning something ordinary into something almost magical. The idea fascinated him. If he could make glass, he could build windows, containers, even lenses. But first, he had to understand the chemistry behind it. He began by examining the resources around him. The riverbanks were lined with fine, pale sand that sparkled in the sunlight. He scooped some up, feeling the gritty texture slip through his fingers. He knew that sand was mostly made of silica, the main ingredient in glass. Scientific note: what is glass? Glass is made primarily from silica, silicon dioxide, SiO, which is found in sand. But pure silica melts at a very high temperature, about 1700 degrees Celsius 3092 degrees Fahrenheit, which is difficult to achieve in a primitive kiln. To lower the melting point and make the process practical, ancient glassmakers added two key ingredients: soda, sodium carbonate, and lime, calcium oxide. These act as fluxes, helping the silica melt at a lower temperature and making the glass more stable and durable. Akshat needed to find natural sources of soda and lime. He remembered that burning certain plants, especially those that grow near the sea, could produce ashes rich in soda. He searched the river's edge and found reeds and grasses. After burning them in his fire, he collected the white ashes and tasted a pinch. They were salty, a good sign. For lime, he looked for shells and limestone rocks along the riverbed. He found fragments of old snail shells and some chalky stones that fizzed when he dripped vinegar from fermented berries onto them. Scientific note: natural sources of soda and lime. Soda, sodium carbonate, can be obtained by burning salt-tolerant plants, whose ashes are rich in sodium compounds. Lime, calcium oxide, comes from heating limestone or shells, calcium carbonate, to drive off carbon dioxide, leaving behind quicklime. When mixed with sand and heated in a kiln, these materials form glass at a much lower temperature than pure silica alone. He carefully measured out his ingredients. About 7 parts river sand. 2 parts plant ash, for soda. 1 part crushed shell or limestone, for lime. He mixed them together in a clay bowl, then placed the mixture in a small crucible, another clay vessel he'd shaped and fired in his kiln. He built up the fire, feeding it with dry wood and adjusting the vents to keep the temperature as high and steady as possible. Hours passed. The mixture began to glow, then slowly turned into a bubbling, viscous mass. When it cooled, Akshat broke open the crucible and found a cloudy, glassy lump. It wasn't perfect, full of bubbles and rough edges, but it was unmistakably glass. Scientific note: primitive glass formation. The first glass is rarely clear. It's usually cloudy or greenish, full of bubbles and impurities. But even this rough glass can be shaped, chipped, and eventually polished into useful objects. The key is controlling the ratios of sand, soda, and lime, and maintaining high, steady heat in the kiln. Holding the glass in his hand, Akshat felt a thrill of accomplishment. He had taken the raw earth and, with fire and knowledge, created something entirely new. It was a small step, but it opened the door to countless possibilities: containers for safe water, sharp tools, and, perhaps one day, the first lens to study the world in even greater detail.